All right, so now we are moving on to day 3 of section B. All right, so it's our very last day of doing this section, and then we have one more section then our test, and it's the exact same objective still as the other ones, and that's just to understand and apply the index law. All right, we're going to just learn one new law today, and then the rest of the video we're just going to be combining every law that we did learn in much more challenging problems than what we were doing in the last couple sections. All right, that is it that we're going to do for this video, so let's get started on that now. All right, the last law that you guys need to know about is this law here. And what this law says is if I have any base raised to a negative power, that can be rewritten as 1 over a to the n power. All right, so essentially we are just flipping it and making our power positive. All right, so if I give you x to the negative squared power, this is equivalent to 1 over x squared. All right, in order to make that a positive power, we need to take its reciprocal and it makes it positive. All right, one of the common mistakes that people make is if I give you negative 2 to the negative second power, they will write that this is equal to negative 4. And this is incorrect. All right, what you would have to do first is to get rid of the negative, we flip it, so it becomes 1 over 2 squared, and then we can take the 2 squared, which is then going to be equal to 1 over 4. All right, so it's important when you have a negative power that you can go ahead and rewrite it as a positive power by taking its reciprocal. And the same thing happens if I give you 1 over x to the negative 2 power. This is equal to x squared. So in order for me to make this positive, I need to move it to my numerator since it's in my denominator to begin with. In order for me to make this one positive, since it's in my numerator to begin with, I need to move it to my denominator to make it positive. So we're simply just changing the position that it's in. If it's in the numerator, it goes to your denominator. If it's in your denominator, it goes to your numerator. And then it makes our power positive. So the power does not get distributed, like I wrote here, 2 to the negative second power does not equal to negative 4. Right? This would need to be made to moved to our denominator in order for us to have a positive power. All right, so let me just erase this and go through it one more time. All right, and I'm going to go through it with a few examples in one. All right, so if I give you x to the negative squared power, y to the negative cubed power, and z to the negative fourth power, if I want to make these positive, since this x is negative and it's in my numerator to begin with, I need to rewrite it in my denominator to make it positive. Since this y is in my numerator to begin with and it's negative, I will need to rewrite it in my denominator to make it positive. And since this z is in my denominator to begin with and it's negative, I would need to move this to my numerator to make it positive. All right, so whenever we have a negative power, we simply move it to the opposite numerator or denominator that it's starting in, and it changes our power to be positive. All right, and we always simplify to a positive power. We never leave it to a negative power. All right, so the first one's very easy. It's just rewrite it without brackets or negative indices, so negative powers. So for a, since it's understood to be over top of 1, we just need to move it to the denominator. So it'll be 1 over 2 squared. Right? It doesn't say for you to evaluate, so you can leave it as 1 over 2 squared, especially because it's saying to rewrite without negative indices, so they want you to keep it in index form. Or actually, if this was on your test, I would want you to go ahead and simplify it even more since you know what 2 squared is, so you will say it's just equal to 1 over 4. All right, so for this next one, for B, this one's a two-parter. First, we have to be able to apply this 5 to the 0 power, and then we have to be able to apply this negative 1. So we know anything raised to 0 is 1. And then in order to make this a positive power, since it's in the numerator, we will just flip it to our denominator. And now we can combine these. We can multiply this by 5 over 5, so we get common denominator. So 5 over 5 minus 1 over 5. And that will give us the final answer of 4/5. All right, so you must keep going as much as you can. All right, then the last one for C, we have 2 over 5 raised to the negative second power. Now, the good thing about this one and why I wanted to go through this is when we have a fraction being raised to the negative power, we simply just take its reciprocal, so it becomes 5 over 2, and we can make this positive. All right, if we flip the fraction that's inside of our power that's negative, it makes our power positive. And now we learned before that we can distribute this power in, so it becomes 5 squared over 2 squared, which we know is then going to be equal to 25 over 4. All right, so these are good examples to go through as well, because in this first one, the entire 5x is being raised to the negative first power because it's in parentheses. So that means if we want to make this into a positive exponent, since everything is being raised, so we can flip it. All of this is understood to be over top of 1, so its final answer is 1 over 5x. We don't need to write to a power of 1 because everything is being raised to a power of 1. Another way that you can do this is we can distribute this negative 1 power into both, and we can get 5 to the negative first power, x to the negative first power. And to make this 5 positive, or 5 power positive, we know we need to flip it. And then to make the x powers positive, we need to flip it. So you can do it either way if you want, but when you have everything being raised to a negative power, it's easy to just flip it all at once. All right, b is a little bit different because it's not written in parentheses. So the only thing that's being raised to this power of negative 1 is this x. Right? It's something that we went through in the very first section of this chapter. If it's not in parentheses, everything is not being raised to that power. So this will remain, 5 will remain in the exact same position because it's raised to a positive power 1. And then the x just needs to be rewritten in our denominator. Right? And then for c, 3b squared to the negative second power, same thing as I said before. Everything is being raised to this negative second power, so we can just flip everything on the inside. And now it's all being raised to the second power, so we can distribute the second power into everything because it's just being multiplied or divided and nothing's being added in between. Well, 1 squared is 1. We will then get 3 squared, and then our power to a power we multiply, so it's b to the 4th. And we know 3 squared is equal to 9, so it's 9b to the 4th. So that will then be your final answer. All right, now the next few problems we go through are going to be combining pretty much everything that we did so far in this section into one problem. We're going to do, I think, 2 or 3 of them. All right, I am going to go through different ways that you guys can answer this. And the first one is going to be the exact same way I was doing before. All right, so when we have a negative power, you can first figure out to get rid of that negative power by just flipping everything it's being raised. So everything on the inside that's being raised that power. So that means since all this is originally written in our numerator as is, I'm just going to flip everything. And everything stays exactly the same if you are just changing the power on the outside. So you see, since I'm just changing this negative power, when I flip everything, this f to the negative 3 still remains the same because I was changing this power and not this one here. All right, and then after you do this, then you can go ahead and simplify everything on your inside. Well, I have an f to the negative 3 power, so that means I'm going to move it back up to my numerator to make it positive. So this then becomes f cubed over top of g to the 5th and h to the 8th power. And now I can distribute this power into everything. And I know power to a power I multiply. So this becomes f to the 9th because it's 3 times 3. This becomes g to the 15th because it's 5 times 3. And h to the 24th because it's 8 times 3. And that will be your final answer for this question. All right, for this one, I'm going to do it a little bit differently. Rather than getting rid of the negative power first, I'm going to go ahead and I'm going to simplify everything that we have on the inside, right? Because you can do it either way you want. So that means I'm going to get rid of this negative power first. So in order to get rid of that negative power, I need to move it to my denominator. So it's x cubed. This y to the negative 8, in order for me to get rid of this one, I need to move it to my denominator as well. So it becomes y to the 8th. Right? This x to the 4th is already positive, so it will remain x to the 4th. And then this y to the negative 2 I need to make positive, so it will become y squared. Right? So I moved everything on the inside first, and since I wasn't dealing with the outside, that still remains negative. And now I'm going to simplify. When I'm multiplying like bases, I know I can add my power, so this then becomes, let me move this a little bit over to the side, this then becomes x to the 7th. Right? Here I have y squared in my numerator, y to the 8th in my denominator, so that means I can cross out 2 of these, and I will have 6 remaining, so it becomes y to the 6th. And whenever I cross this out, there's a 1 that's left over, so it becomes 1 over x to the 7th, y to the 6th. Right? Now, since I simplified everything on the inside, I'm now going to get rid of this negative power. And in order to do that, I need to take the reciprocal, what's on the inside, so it becomes x to the 7th, y to the 6th. And then this becomes a positive 7. And now our rule is we can distribute this power in, and power to a power we multiply. So 7 times 7 is 49, and 6 times 7 is 42. All right, so even if you were to flip it first and then simplify everything, you'd still get the same answer. So it doesn't matter which way you do this. It's your preference. All right, so here's another problem in which we have a lot going on. All right, so since everything is positive to begin with, you can either simplify what's on the inside first, or you can distribute the power. I'm just going to distribute the powers first. That way, I know I don't forget to do this later on. So then this will then give me m to the 18th, p to the 30, over top of n to the 42, times, this will give me m to the 6, because this 3 will then get distributed to everything, n to the 0, because 0 times 3 is still 0, p to the 9th, over top of m to the 12th, n to the 6. All right, and now, since everything is being multiplied here, we went through a worksheet that was very similar to this. We can just start simplifying everything across. So what I mean by that, well, first off, n to the 0 we know is going to be equal to 1, so I can get rid of that. All right, here I have m to the 12th on my denominator. So I know that this m to the 12th can be reduced to m to the 6th and cross this one out completely, because there's 6 of them. All right, then I have 18 here and 6 here, so this 6 can cross out completely and leave this as m to the 12th. All right, I have no other n's left in my numerator, so there's nothing else I can cancel. There's nothing that's in the numerator or denominator, so now we just go ahead and multiply across. So when we multiply across, we just have 1m. Hold on. All right, it's not letting me delete this right now, so I don't know why that was doing it like that. But we had this 1m to the 12th, so it remains. Here we have p to the 30 times p to the 9th. So when we're multiplying like basis, we add them, so it becomes p to the 39. And then on the bottom, we have n to the 42 times n to the 6, so it becomes n to the 48. Right? I apologize for these things, but it's not letting me erase it, so my software was just messing up a little bit. All right, but you can do this any way you want. If you wanted to, you could have simplified everything on the inside first and then distributed your power, or you could have did what I did by distributing your power and then simplify at the end. It is your call.